Hey everybody, I'm on a mission to build the ultimate RC crawler wheel set. I have an image in my mind what the final design should look like, but like any engineering or design project, I want to go through a couple rounds of iterations to prove it out. Look for improvements, be sure I didn't overlook any aspects. This is going to be a 2-2 wheel, and people have started calling this type of wheel a drop center wheel, and the goal is ultra low center of gravity. On this channel, we look at the science behind our grown-up toys. Very few ideas are entirely original. They all draw inspiration from prior designs, or in the patent world, what's called prior art. For this design, I was inspired by the deluxe OG loaded dice wheel. There are several other similar designs from people building superclass wheels. Team DJMRC is doing something very interesting here. Barry Belvedere made something at one point that he called rock magnet wheels. I love that name, Barry. And finally, just this week, Deluxe finally showed not one but two upcoming wheels. A more traditional loaded dice beadlock wheel, if you can call any of these traditional, and a more extreme version that will be the new benchmark for low center of gravity. They don't even have a name for it yet. In this video, I'm going to show you my first prototype. I'm not sure I'd even call it a prototype. It's more of a proof of concept. I want to learn what works, what doesn't, and this first version won't look anything like the final version. It's just a quick, relatively inexpensive test platform. After this proof of concept, I'll probably do at least two other prototypes that will better resemble the final design. Here are my targets for this project, more or less in order of priority. Ultra low center of gravity, lower than anything that's been done before. Beadlock, no glue. Keep a high degree of foam. I don't want to compromise too much traction and squish. Lightweight, which likely means carbon. Strong, which also means carbon. It should be manufacturable, and ideally the concept can be scaled to all sizes. 2.2, 2.2 low profile, 1.9, and even 1.0. Let's check out the first proof of concept. So here's where I'm starting. The idea is to get the center of gravity as low as possible. And to do that, you need to drop it down inside the tire well. So I've got this one assembled here, and just to give you a preview, the weight sits down here within the tire. That's really the absolute best place that you can put weight on your vehicle. If you take out weight everywhere else, and you only add it down here, this is the lowest possible point on your vehicle where you can add weight. Now, I have seen people put BBs in their tire. I've seen a full-scale vehicle put water in their tire, and there are some issues with that, but it doesn't really work for a crawler because we climb such steep angles that, let's say this is the hill you're climbing. If you've got water or BBs in your tire, it rolls down to the bottom. And you really want your weight as far forward at the angle you're climbing as possible. A lot of people don't necessarily clock their weights properly, but when you're climbing 70 degrees, you want your weight as forward as possible, not down. Down doesn't hurt, but the further forward your weight is, the better. So when your vehicle's on level ground, ideally you want this clocked forward about 70 degrees so that it's horizontal when you're climbing 70 degrees. That's how I look at it. And with this weight being forward, that's what keeps your front end from lifting when it's trying to rotate around the rear tire. I'll do a more detailed video on that later. Now here's a typical tire foam, and I want the weight down as low as possible. So I've printed a bunch of parts here, and I'll show you how they go together. This was not super expensive, well, it wasn't cheap, but also was not crazy expensive. Again, this is just the first prototype. So let me just start with this, and it'll become more clear. Basically, this is going to be the wheel here. And this should resemble a lot of other wheels you've seen from Deluxe and other people. Basically, two plates tied together with standoffs. Now, I've made this about the diameter of a foam insert. So the foam is going to go around like this when it's assembled. This is what it's going to look like on the inside. And the weight hanger is going to be right there. The biggest challenge is you want as much foam as possible so your tire compresses and conforms to the terrain and gets traction. But you also want your weight as low as possible. So your foam and your weights are battling for space against each other. You want a lot of foam, but you also want your weight as low as possible. So the gating item becomes the thickness of the outside of your wheel. Most designs have some sort of bridge tying the left side to the right side. You have to have something tying the left to the right. And this is the pinch point. This is a 4.5 millimeter diameter standoff, which is pretty common. And if you can minimize this distance, you can add foam and lower your weight. So this 4.5 millimeters, I want to try to get rid of. I'm only using 5 points of connection across the two. And what should happen is this will compress in between these two struts, which is a good thing. That gives you some squish, but you don't have squish here. So you've got a stiff part and then a soft part, and then a stiff part and a soft part. Now, one thing I want to test is that a benefit? It could be that these 5 paddles actually help you. If you're trying to climb up something real steep and you're stuck in here, this paddle might sweep around and pull you over. So there could be a benefit to having these paddles underneath the tire giving you traction. I don't know. That's one of the things I want to explore. However, I do feel like this is going to be too soft. So I need to reinforce this with as thin a material as possible. So that's where this leaf spring comes into place. This is only a 0.5 millimeter thick, and I'm going to wind this up and put this on the inside. Oh. This will be a carbon fiber leaf spring, only 0.5 millimeter thick, and that's going to sit in here like this. And that's going to give me some support and some suspension. But first I got to make a loop out of this. So, let's see if I can do that without hurting myself. So check that out. Now I've got a leaf spring. And I'm going to put that inside here. Okay. Now this part where the leaf spring overlaps is going to be stiffer. So I'm going to put that underneath one of the parts that's already stiff. Now the stiffness of the spring can be tuned by making it wider or narrower and also thicker. You can't really buy infinite thicknesses of carbon very easily, so I think making it wider is going to be the faster way to fine-tune this. All right, so the second part will be to put this on. But this doesn't go in as it stands, so what I got to do is build this into the wheel first, so it's trapped. Now that's not going to be the most convenient ultimately, and I played with a bunch of different ways to get the weight through this hole and install it, and it just creates too many compromises. And if I'm going to build the ultimate wheel, then the weight hanger is going to have to come off with the wheel so that I don't compromise any performance. Now a little bit about the weight hanger. These are 3D printed stainless steel. This will mount to a standard deluxe mounting position. In this case, this is a portal cover. And this will be carbon fiber in the future. The reason being is the carbon will be lighter, higher. You can improve your center of gravity not only by adding weight lower, but removing weight higher. So to me, it makes sense for this to be carbon, so it's light, and that skews the weight bias lower. So I've got these two holders, and if you've seen my other videos, these get loaded with cubic tungsten cubes. I've done a lot of experimenting with tungsten. So if you take a look at this, these cubes pack much tighter and lower than cylinders. Now cylinders are a little bit more common than cubes, but it's not that hard to find cubes. So I design all my hangers around cubes, and most hangers are designed around cylinders. Oh man, this is one of my favorite materials. It's beautiful. Also, you'll see what I did is I filled in between each of these cubes with a little fin of stainless. So all of these fins between the two halves add up to another 1 to 2 cubes. So I don't want any air packed in here. And the other benefit is these ribs are on the bottom half of the hanger. So this really packs the weight low, low, low. So this is what's going on the inside. And I've got two widths to these right now. I've got a 2-row or a 3-row, or you could build a 4-row. But 4-row is really wide, very hard to fit inside, and very heavy. Already, this one here is 185 grams. That's really about the most weight that I've seen someone add, and about the most weight that I can imagine myself ever needing or wanting. So I might actually switch to a 2-row, but this is the very heaviest option, a 3-row. And when this is in carbon, we'll probably lose 6 more grams. But that's pretty heavy. 185 grams. That's heavy for how small this is. Okay, so let's try to put this together. I need to put on now, one thing I can see already is that these holes are a little bit to the outside, and it's making it a little bit difficult to put the bolts in. So I've reverse engineered this a little bit off, which is the purpose of a prototype. So I'm going to go back and close down this bolt circle probably by 0.2 millimeters, and then I think the holes will line up a lot better. Always do your final tightening in a star pattern to ensure even torque. And go around twice. Now I'm going to put the weight hanger on the inside, and I'm going to make sure it's offset to the outside. Before I do this, I'm going to make it easy on myself and install these bolts. And also I need to decide what orientation I want this in. So I want this to be clocked forward. So it goes this way. I'm going to clock it forward. This is actually going to be the left wheel, so I'm going to clock it this way. So I want to do this hole. And I'm going to make it easy on myself by using these plastic washers, which push on and stay in place. So that'll hold my bolt in place. Right here. So I'm going to have a little bit of travel from my leaf spring, but it will eventually, with enough force and enough pressure, hit that weight hanger. Again, that's something I want to test to see if that's an issue, see if I want this to be stiffer or maybe there's a different design altogether. All right, there's the basic concept. And what we're going to do is take a look at the foam. All right, so again, I don't love these stiff spots. I haven't figured out a way around this yet. There may not be a way around it. You have to have the left and right sides tied together somehow, but I think I can make this thinner. Again, this is just a prototype made from off-the-shelf parts, so we're going to do better on the next version. All right. So I've got the real soft foam here, then I've got a little bit of squish on this leaf spring. I'm pretty happy with that. And again, we're going to find out if these paddles help pull you over or if they have other drawbacks. The other thing we need to test is, can we stretch a tire over this wheel if it's this big? Maybe impossible to even get your tire on. So let's see if that's an issue. All right, so we can't get the tire on. That's good. So how does a bead lock work? Well, you've got this outer ring, and then you've got this inner ring. And then you've got the bead lock clamp out here. So the bead of your tire is going to drop right in this slot, and then this will clamp on the outside. Pretty straightforward. Now I printed 2 different thicknesses of this bead so you can accommodate different tires. And I paid to have these dyed blue, and you can barely tell a difference. It's got a hint of purple to it. So these are a little bit thinner if the tires are thinner, and these are a little bit thicker if the tire bead is thicker. So we will be able to pick just the right pinch on the tire. This will be carbon fiber in the next version. And I think it's probably easier to pop these in after the tire is on. Now on the outside, same basic concept, but I wanted to try something else. But I wanted to try something different. So on the outside, I have this hubcap, I call it. And what this does is simply cleans up the outside. You can't see the 6 bolts holding the hub on, and this was inspired by 1980s Lamborghini Countach that had 5 round circles as their design aesthetic. Looks pretty dated now, was cool in its day. So I have this outside hub, but really this hub is doing the same thing as a simple ring. I don't know if I'll keep this, if it makes sense or not, but we will see. And then I'm probably also going to put on one of these tuning rings from Crawler Innovations. Now, Crawler Innovations recommends using a tuning ring on the outside. That's so your tire doesn't fold over. But I'm probably going to put it on the inside because I do a lot of hangs. And this gives you a firmer surface on the inside to hang from. So I'll probably put this on the inside. Okay, not bad. The other thing about having those 5 arms stick up is that I hope it'll add some lateral support to help the tire from rolling over. So with those 5 spikes sticking up, I'm hoping it'll improve the tire's lateral stability. We'll see. Okay, that might actually be a problem because it's not nearly I probably need to cut this bigger than this. So I should probably cut these out. Using my curved Lexan scissors. Does not have to look pretty because it's on the inside. Okay, now the part that's super annoying on a prototype. These are all held on with nuts on the back side. So these are going to be a colossal pain to install, and when I get to the real version, I will definitely fix this. Okay, first one installed 20 minutes later. Okay, got all the nuts installed, and that did take quite a while, but that's sometimes the nature of prototypes. And what I've learned is we should definitely make this easier to assemble, which of course is part of the plan. Okay, after much travail, I got the outside bead installed. It looks like it's on there really solid. It looks like the diameter of my beadlock is good. I could probably make this beadlock a little bit thicker so it hides the edge of this tire. This beadlock will be stiffer and stronger if I make it a little bit thicker. I plan on countersinking these bolts so they're flush, so that it doesn't scrape against anything. I want this whole outside completely flat and smooth. So this part will be carbon. It'll have a countersunk bolt head that'll be flush. So I may need to add some strength to this because that's a big hole and a big chamfer across there. So it looks like I could make this a little bit thicker if I wanted. I'll maybe go to 3 millimeters instead of 2.5 on the beadlock rim. All right, so we're like half done. Now we got to do the same thing on the other side. All right, I can already tell that this is kind of thin, so I definitely want okay, that tuning ring is also going to kind of help hide the bolt heads that are in there. Okay, you can see there's a soft spot in between those 5 supports. All right, so I'll put this outer beadlock in place. In the future version, I'll probably glue or tape these in place. It'll be a lot easier. All right, what we're also learning is that having these things self-aligning will be very useful going forward. All right, so I got 2 in. If I haven't said it enough already, this is just the first prototype. It's normal for things to be this hard to assemble at this stage. And the goal is we will make it easier. I will make it easier on myself. Some of the earliest Apple products had custom screwdrivers because they just couldn't use normal screwdrivers. All right, this is a lot easier on this side. I love these curved Knipex pliers, or Knipex, as a lot of people say it, which I think is correct. Okay, we got it built. Nice and squishy. Kind of hard to tell where the foam is in there. You can definitely feel the soft spots in between those stars. I don't know if these internal paddles are a benefit or a detriment, because you can see you've only got a small amount of flex right here. You've got quite a bit of flex right here, which is good. I'd love to have this much flex everywhere. And I can also feel that leaf spring in there. I feel like the stiffness of that leaf spring is pretty spot on. That's a great starting spot. All right, and you can see we've got the weight hanger still floating around in here. And I can feel that outside foam. That's nice. All right, let's put it on the car. All right, so now let's try to get the wheels on. What I've got to do is grab these two screws from the outside. So one thing to improve is how can we get better access to these screws from the outside, because it's not as easy as you would have thought. Okay, this is also a colossal pain, and this is how it'll be in real life. You're going to have to access your hanger bolts through here. So we need to find a way to make that much easier to find the bolts. All right, double check everybody. Something somewhere is grinding. This is why you build a road prototype. I think I know what it is. So, wheels got to come off. Okay, I think the clearance, yeah, look at that. It's rubbing right here on the top of this portal. And I noticed that on the other side as well. So I'll definitely have to make more clearance on the next version. I think for now what I'll do is Dremel I don't know why this sticks up so high anyway. I don't really love grinding off the beautiful anodization, but I did it anyway. So I ran into a number of issues, which is the purpose of a prototype, and I had to reset a little bit. So I completely disassembled the wheels. There was some rubbing going on the inside, and I took the wheels on and off more times than I can count, and it was a colossal pain to put them on and off. But I needed to remove the tire, start from scratch, find out what was interfering. And what I found is that some of the bolt heads on the inside were rubbing right here, and also the screws that were holding the leaf spring together were also rubbing down here. So I removed the screws from the leaf spring and replaced it with some really strong tape. I don't know if this feature is going to make it in the final version, so I'm okay with the tape solution for now. Hopefully it'll stay together. I also went and put what's called PEM nuts pressed into each of these locations. So this adds a threaded insert to each of these holes. This is going to make it a whole lot easier to assemble. I don't have to hold the nuts on the inside with pliers anymore. And this could make it onto the final version, but I've got a little something else in mind. This is great for prototyping. And I also put a couple drops of CY on this ring to hold it in place. So it's much easier to assemble now, and some of these ideas may or may not carry over to the final version, but at least now I can get my prototype back up and running and test out some other things. So here it is on the car. I also had to make sure these weights were centered left and right. They needed to be adjusted a couple millimeters to make sure they didn't rub on either side. So now I've got it all free spinning, no interference. Time to put the foam and tire back on, and we'll test it out on a track. So I've got the wheel on the front right, and on the front left I've got a standard wheel. And look at that hopping. When the standard wheel on the front left is down, it's nice and smooth. But when the weight's on this new wheel, you get this bouncing and this hopping. I think that's going to be an unintended negative to this internal starfish design. At this exact spot, I've never been able to crest the peak going slowly. I don't know what I was expecting, but I was hoping for an improvement, but it still is hanging just below it. And the reason being is that I may have changed the position of the weight, but I didn't change the total weight. I haven't added any additional downforce, so I haven't added or subtracted any traction. I may have shifted a very small amount of traction to the front wheels that was on the rear wheels, but I haven't added any traction. So it actually shouldn't come as a surprise that this isn't an improvement. But I can tell you where there is an improvement, which makes more sense, is when you do a slight dynamic throttle bump. In the past, I was about 50-50 whether the vehicle rolled forward or tipped over backwards. And now, in every case, the vehicle falls over the top. At no time does it tip over backwards, where in the past, there was a good possibility it could go either way. So that's a pretty big plus. So after building and driving this first set, I have a pretty good idea what some of the enhancements need to be. Here's a quick teaser of what the next version should look like.